Welcome back, everyone. I can still see many people after lunch, so hopefully this roundtable will be living up to your expectations that you return from lunch even. Let me introduce my highly esteemed guests today. We have Professor Péter Korondi, who is a full-time professor from the University of Debrecen. We have Zoltán Sas from Rexroth, who is a didactic sales expert at Rexroth. We have Naoyuki Kubota, professor at the Tokyo Metropolitan University. We have Charles Phiri, who is subject matter expert on AI at JP Morgan. And we have Professor János Botzheim, who is the head of the Department of the Artificial Intelligence at ELTE. Today, we will be talking about intelligent robotics and the many aspects of what intelligent robotics could be and what the future is about in intelligent robotics. And before we get into any of the demonstrations, because we have prepared 3 really small demonstrations we can talk about, I would like to start with a really simple question, and I would like to ask you to please answer this question. What do you consider the first robot in history? János, can you start, please?
The first robot around the middle of 20th century started to begin this topic, I think. So I would say that, so like Unirobot and Unimation and this kind of robots.
Okay, so you are on the classical track of this definition of the robotics, which is like post-industrial in this sense.
Yes,
okay.
I'm on that side.
Charles, what do you think the first robot was?
Unfortunately, I have to agree on that one because I don't see any extension on that I can actually add that is really meaningful.
Okay, so we have 2 post-industrialist definitions here. Professor Kubota, what do you think?
Okay, according to the definition of robot, so we have to consider the aim of the robot. Okay, so automation or something. So the first robot is just automata or karakuri in Japan.
Okay, so you are also saying that this is low level of modern industrial automation around the middle of the 20th century, somewhere around that. So, what do you think is the first robot in history?
Actually, I'm not a robot expert, so what does it mean, robot? What is the real definition of the robot? That can be I would say, the single source of truth, and I have really experienced and really honored colleagues here. Maybe they can answer that, and after that I can do some guessing.
Okay.
So you want the definition of the robot? I tell you my definition. It's not mine, but my favorite one. When AI meets the real world.
That's definitely yes. That's one definition.
What do you think about
Peter,
that?
do you have another definition? Maybe?
So maybe I have an other answer, but I would like to ask Gabi. Maybe she's more. So actually, this definition from the ethologist, and Gabi is an ethologist. So I learned this answer from Adam Miklósi, who is the head of the Department of Ethology. So maybe it's more authentic if you tell it, Gabi. So please.
So from the, I'm not sure if all of you are familiar with the field of ethorobotics, which is a field that combines ethology, robotics, and human-robot interactions. And that field basically builds on using dogs and certain human-animal interactions as models for developing and designing robots, so for the design of human-robot interactions. And using this definition of this field, we can say that the first robot can be considered a biorobot, called, such as the dogs, for example, which we use as models. And obviously the domestication of robots started like 100,000 years ago. So in that sense, we can say it's much longer ago.
Okay. Thank you.
Thank you very much, and thank you for the quick chip in.
Outsourcing.
So I will really quickly just revolve back to Zoltán. Do you think which side would you choose in this panel? Because we have the industrialists closer to me, and we have the biological definition of the robot at Péter, and
Actually,
continuing in the audience. So
actually, most of the cases I find myself in a cross-disciplinary situation. So I would agree with both, because I really like I would say the essence of the old and ancient things, which shouldn't be forget. So this is why I really like that answer. Concept-wise, it's true, it can be originated, but mainly the modern robotics, actually the concept originate from that concept, even not willingly, but in case of the modern robotics, yes, I would agree with the colleagues there.
So you say that there should be modern robots which should be domesticated, and
well, I see I have to choose.
yeah, no.
All right.
This is the synthesis.
No pressure.
And actually, just to be honest, I have a video about domesticated modern robots. So if we can go for the first demonstration, maybe then we can talk about this. So hopefully we will see on the next slide. So about this news release, there was a really interesting moment, actually the last moments of the video, where the robot is just waving on top of the steps, but it doesn't take any steps down there. So I would be interested in your opinion on how robots could be domesticated in this way. What kind of navigation and interaction capabilities should they have in order to be able to co-live and co-work with human workforce and human people in the everyday lives? And I cut the conversation somewhere around Péter and Zoltán. Could you please?
Okay. So what is the most important message of Gabi's answer? That from now on, the robotics is not an engineering competency totally. So we have to include quite far sciences, for example, biology, ethology, psychology, which was mentioned in the first presentation, that we have to learn that areas as well, and we have to find the synergy.
All right, let me share you an example. It really happened. We installed 5 AMRs in one factory, and during the first 2 weeks, the workers were actually really offensive with them. They didn't want to accept them. So there was somebody came up with a really brilliant idea. The AMRs have, I would say, a screen in the front, and they got names. The action started, Arnold, Sylvester, so on. And, after a few days, they were accepted. So, it's a simple thing. It was not a humanoid robot, but still a robot. And the people thought the robot actually threatens their job. And just giving names to them helped a lot to accept them. And this is the reason why I would say they are if they are just robots following some protocols, it won't be enough. So I would say the waving, it's a good way how to, I would say, make them accepted, and it's necessary. Otherwise, there will be just like an ordinary tool, and especially in case of humanoid robots, somehow they will be integrated into your life. So I wouldn't say it's socialization. I don't really good with the terms, but they should be a little bit more than just a simple object. So, but we have to really find the proper equilibrium, because they will never be human, but they won't be just ordinary object.
I would refer back to János's definition of robot, which is a really short definition, but it says that it needs AI in the body, or in the metal, in the machine. What do you think? And I'm looking at the guys who are mainly in AI here. What do you think is it really important to have really advanced signal processing, according to what the colleagues already said, or could there be a really good robot that doesn't have any high-level signal processing?
So for that we have to define what AI is, right?
Yes. But we cannot use robots to define what AI is, because we have already used AI for robots.
So we have to define AI, and so how is it different from the real intelligence, so human intelligence? What we are doing now is just imitating of the intelligence, right?
Is it enough, or could it be enough for applications?
For
like
solving problems which are solved by the humans, so then robot can also solve, but that's just an imitation. Yeah. Maybe not real intelligence, but we don't know.
So you say that narrow AI is enough, signal processing is enough?
No, maybe narrow AI is not enough, but like strong AI would be enough.
I would give a really, I would bring in a really catchy phrase, which we say in Hungary many times, that Japan is at least a decade ahead of Hungary. Do you think Japan is closer to strong AI in this sense, or are you working on mainly narrow AI right now?
Actually, so in my talk, so I explained my first aim of cognitive robotics is to realize cognitive development based on robot embodiment. So actually, recently, thanks to reinforcement learning, so we try to use deep reinforcement learning, and then in Japan, so many researchers focus on deep reinforcement learning without using traditional cognitive robotics. This is a problem, I think. So actually, so as you know, so many US and Chinese companies develop human-like robots and multi-legs robot. So deep reinforcement learning realize the reinforcement learning through the interaction with physical environment. But they just, such kind of model just learned output to realize stability or something. Okay? So today, so I explain intentional dynamics. So this is really important. So we can train the neural network model in the physical world, but without estimating human intention, so we cannot collaborate each other. For example, so if I want to drink water, of course I pick up like this. But if I want to clean up this area, what is the meaning of this behavior? The aim is different. First one is just I want to drink water. The second one is to put away this bottle. the same action, but different meaning. So therefore, in order to realize human-robot co-working or co-living, so we need intentional dynamics. Okay. Yeah. So we have to go back to the previous cognitive robotics research so much.
So it would enhance our perspectives if we can remotely estimate the intention of humans. Mm-hmm. We in Europe have a really strange position, and I don't know if, Charles, you have digged deeper into it, but actually the AI Act prohibits some parts of human intention, intention recognition. Do you think that, let's say, the legal boundaries on AI and humanoid robots will stabilize the European scene, or will make it fall behind, let's say, for example, the Japanese scene in this sense?
I think when it comes to robots, there are actually many things to actually think about, because you have got first of all, what humans accept as interaction with a robot, and what is acceptable interaction, right? Now, the definition of that is actually in legalese, so you have to actually unpack that, right? Now, on the other hand, if we are looking at, I want to have a robot living in my space, I need to also make sure that that robot continuously learns, because the environment itself is actually changing, so it's non-stationary, right? So if you've got a non-stationary environment, you've got a robot that can actually, even if we take humans, right? We judge others by their actions, not by their intentions. So if I cannot read their intentions, it means that everything that I'm actually talking about is actually interpreted. So if I take the robot's actions described in its own perspective, my actions described in my own perspective, how do you marry that? That's where we actually go back to where you're talking about intention dynamics. But on the other hand, you've got the affect, right? What is it that I accept about the robot being in my environment in order for me to make this a useful tool? And what is computable?
Definitely, and this raises another question in me right now. Yeah. Can we do quality control on the internals of robots, or of social or cognitive robots? What do you think? Can we somehow make sure or guarantee that some kind of dynamics will be built into it, which is helpful for humans?
So, as an engineer, I cannot answer to this question. If I face this problem, I go to Gabi and I ask her what we should do, or I go my colleague in Debrecen University, I mean a psychologist, and I ask them how can a human being show the intention. I agree with you. Showing intention, very, very important. But I don't know, as an engineer, how can I do it? So that's why I ask psychologist and ethologist. She is here, but unfortunately she don't want to sit among us. She afraid of the engineers.
So if I can add to that one, right? So in order for us to say that this robot is actually working correctly, right, we need to know what is the specification, right? If that specification is not stable, we've got a satisfiability problem. So it means that anything that we can actually do beyond that is a matter of how do we fit into that specification, and is that specification good enough? How much data do you have to actually create a good enough specification?
Do you think we have enough data yet? Or this is something which science and technology has to answer in the upcoming decade?
Sorry, I mean, let's take two sensors, right? If I want to actually sense the position of the table, right, I'll actually place sensors in the direction that I know that the table is actually going to move, in order to actually minimize the number of sensors that I'm going to use, right? If I cannot tell the gap in between, then it means that I've got sparse data, right? I need to fill in that information. So data in real life is actually sparse. because we've got real costs, we've got real resources that we have to work with. But if there was a way of finding out that information without me having many sensors on this, then that's that's the direction that I'll go in. So we've got simulations that we need to actually make in order to actually fill in the gaps. And we've also got the to infer the gap between the data in a way that does not actually cause any losses.
My last question before we move on: can we scale this up in a way? Is there a way to scale it up? Have you seen any social robotic simulations that could be scaled up into production or to manufacturing? Or this is something which hasn't been touched by the technology yet?
Well, actually, I'm not an expert in AI and in robotics as well. But if we should not rush. That's the problem. We want everything in advance. And that's the biggest problem. It should be a little bit slowed down because it can be a really useful thing, a really resourceful thing for the whole humanity. But if we rush, it can really strike back. So I would say we should define certain use cases, fields we should be really focused on at first, and just really put a lot of efforts. I would say we should decrease the complexity, the chaos around that whole topic. It's a typical research perspective, I would say, and we should do the evaluation. And when we have the data, we can draw the conclusions. After that, we should go further. Because for me, as an outsider, it seems to be we want everything in advance. And do we really have to rush? I don't think so. That's just my opinion.
So maybe a little bit opposite. So I grow up 2 kids. Maybe tomorrow one of my son will be in the ELTE. And I know it takes a very long time. So first I had to teach my son, please say hello to everybody. So that is the very first what I had to teach my kids, to be socialized. No, of course they learned a lot, but it is a very long time. So I think we have to start think how can we integrate the robot when technologically it will be ready for really live with us. Until that, we have to, let's say, educate the robot. And believe me, it is very time-consuming period. Okay.
So what you said is whenever we have a robot that can live with humans already safely, then that it will accelerate the progress. But this is a gap we have to close first.
So at this moment, we are very far from a really socially integrated robot. But as a researcher, we have to work on it because maybe it will be too late. So the technology really growing up it is very fast. The technology is changing every day. So it's very difficult to follow it. But that point of view needs more and more, let's say, consideration. We have to be more wisdom. Mm-hmm. Okay, but sorry, I speak too much.
Yeah, thank you very much.
But, so he's talking about education in real life and using real intelligence. But of course, in artificial intelligence, things can go much faster, right? So with machine learning and similar techniques, the AI can learn like playing chess within 1 hour, a much higher level than a human. So this process in the machine world is much faster than in a real world. So maybe we can have a faster progress, I think.
Sorry, maybe I can tell you. Do you know Archimedes? He told, give me a fixed point and I can move the Earth out of its position. Do you know that? Yeah. Nowadays, the scientists dealing with AI say, give me a very stable fitness function and I can solve everything. But very difficult to find this very stable fitness function. I think it is. It takes time to find it. So if we have this proper fitness function, of course we can solve everything. But do we have this exact fitness function for all kind of problem? So that is my question to you.
I think we do not have, but I have a video which takes us a step closer to finding this fitness function, and it's on the next slide.
Sorry,
actually.
may I have
please,
a
please,
quick
please.
remark? Actually, yes, they can learn very fast, but maybe the humanity need more time to learn how to handle. So this is why I told you.
So that's a mutual learning between the humans and the robots. So humans should also adapt to this situation.
Yes,
right?
but we forcing the AI to evolve much faster than how we can integrate and understand them. So maybe we need more time. And well, I'm not against the socializing of the robots. Maybe it's the best if the robots can be together with the younger age group. We can learn a lot of patterns from that. But still, the children learn, I wouldn't say slower, I would say much more complex way. So this is why, according to my eyes, it's not slower, just more complex. But the complexity requires more time.
I think we can all agree in that, and actually, the lead AI scientist of Meta also agrees in that. So
I don't know him.
His name is Jan LeCam, and I have brought one of the short videos they attached to their new so-called large world model. So let's watch it. I think the most interesting part about this model they released last week was that instead of trying to model what is the next word, what is the next token in a text distribution, they trained a model that is capable of filling in word frames, like from multiple modalities, like motion, audio, visual information, and also the meaning in text, of course. And it's not just able to predict continuations, but it's also able to fill in missing frames or explore alternative possibilities. So how do you think this kind of upscaling of AI, which we have observed in the last 3 years or maybe even 4, will change the world of robotics? What happens if what worked with language will work with real words as well? Because nobody expected that large language models will be so successful. So please, János.
So what is happening here, I think, is that we just build a big brain which has some kind of representation of the world, right? So this can be, of course, very smart and can solve problems, but I feel what is missing is the cognition and understanding. That's what is missing here. Of course, the representation is okay, learning is okay, but does it have a real cognition?
So, yeah, please.
No. So I wanted to ask, are you sure that we have no such cognition? But I think this is the topic which may be related to the younger generation. So I really would like to know the opinion of the audience, especially from the younger generation. Sorry, the time is running, and roundtable discussion means that we have to discuss with the audience as well. Sorry.
It's totally fine. So, who feels the youngest in the audience? There are some people pointing at each other.
How to answer this question? So who is the youngest?
Anyway, just raise your hands, please, at first. Who would be interested in such an AI application that could interact with real world, that understand the real meaning of real world interactions and frames? Okay, that's most of the AI enthusiasts here. I can see some skeptical people around the right-hand side. What do you think? Would it be a safe environment to educate children in this way, to have a common ground with an AI that already understands much of the world? Would it be a good idea, just to reflect on this? I could see some head shakes from there. Maybe Kinga, can you elaborate on this? Why do you think it's not a good idea? We can hear you, of course, but maybe we have some microphones at the back as well. We can get you a microphone. Peter, we can get a microphone from the back.
Okay.
Turned on? Yeah, great.
Okay.
So I think depends on the age of the child or children. So as I think in the young age, it's more important for them to understand and adapt to the actual human interaction, like how to behave, to how to ask, how to get comfort from an adult, or how to mimic like older but still children. And I think robots are robots. So until they don't have real emotion or act like someone that had real emotion and can express it in a proper way. For example, if angry, I cannot punch the nearest person because it's not right. So managing and controlling your own emotion, that's something that should be learned, and it's a long process. I think robots or robot children interaction is not a proper way for it right now.
But it's, do you think it's just lack of research, or this is your definitive idea on this?
Well, it's my idea, but I cannot really list you some proof or add and cons.
Okay, we have 3 hands raised, so let's move. I think Gabi was the first, and then we can move around.
Yeah, so just to connect what we heard before, I don't fully agree on robot-child interactions not being the right way. I think depending on the function and what you use the robots for, they can be super useful. So we work, for example, with children with autism and or speech and learning difficulties, and assistive robotics can be very helpful. But regarding AI and the use of AI with children, I think that has really high risks as well. So for example, there's just a new study which has been published, I think this week, about not specifically children, but students, about how the use of AI actually decrease their memory, has harmful effects on brain functions, and that was proven by EEGs. So EEG, after just 4 months of heavy use of AI, showed a really decreased brain capacity. And I think that's a really serious consequence that we need to consider when using AI. Also, over-reliance on AI can be a really high ethical risk. And I think when we are developing robots, it's very important that we calibrate we calibrate a good level of trust, which is not going to result in either under-reliance or over-reliance, because both can be very ethically risky.
Thank you. We have the 2 gentlemen, one in front of you and one behind you. let's start at the back. And we will get back to this over-reliance problem, because I think it's important to hear the opinion of our experts here.
On the fusion of two comments that has been done, I would like to talk from my own background. I have over 10 years of experience with teaching the robotics to younger generations, starting from until 5, because if you decrease the intelligence of the robots and with that simplistic sensors, you can help them to learn. And we have seen the very big growth on the algorithmic thinking on the kids with the interaction of it. And the second point about the one that is highlighted, the generative AI, I would like to mention the one that is Google Chrome, or the browsing on its own is very threatened. Like with few wrong clicks, kid can end up with any bad sites that you wouldn't like to see. But this is why there is a parental filterization on top of it. You can track, you can enable. So I think we can easily mimic this kind of technologies to go through the same policies, so that parent can decide what are the limitations kids can interact, but still can play within this big domain still. So I see positive impact within this one. Just wanted to highlight.
Thank you. And this adds another question to our list, after Christian, of course, that can we limit over-reliance or under-reliance with some kind of configurations in generative AI or AI-enabled robotics? But let's get back to the last comment here.
Yeah, so I echo the sentiments of Kinga and the others in terms of pure human-child interaction may not be what is best in the long term. But you mentioned one thing in the question, which I think is hard to guarantee. You said something that understands the world. And that I don't think you can easily quantify in a robot or in an AI. In a human-human interaction, we have the general assumption that the understanding is there because everyone here has a kind of baseline lived experience, which is transferred particularly from the adult to the child in the supervision of the child and how they're raised. I think, though, from a practical point of view, child and AIs for learning will be a necessity, because the capacity for public education and other things is not exactly expanding over time around the world. And so this will need to be augmented in some way. But I think the key here is that in human-robot or child-robot, child-AI interactions, we can't be delegating the thinking process to the AI, especially for a child who needs to learn how to navigate, especially the social aspects of the world that they're in. So I think as a guiding system, it could be useful, and especially as you mentioned with children with autism, where the social interactions between autistic and non-autistic individuals can be problematic, not because necessarily that there's something wrong with the autistic person's way of seeing the world, but rather that the way the worlds are interpreted are quite different. And so you can customize a robot to be able to work in a way that's best with a particular individual's way of thinking. So I think the crux of the point is understanding. If you can really say that the AI and the robot understands the world in the same way that a human understands the world, then maybe there's not too much problem to be had. But I think with current generative AI and foreseeable generative AI in the future, reasoning and understanding is something that is missing and can be somewhat, it's an illusionary aspect of current generative AIs that they have this reasoning capability, but I don't think it's truly there.
They're totally acceptable, so maybe the better definition would be a well-structured representation rather than understanding. So we had 3 questions here. Sorry, please.
Okay, so I want to say many things, but first of all, so I explain one important example of robot-child interaction. So I have used robot partners to ASD students before. Actually, ASD students cannot wait for other interaction. But if we use a robot, ASD student can wait. ASD student can do turn taking. And also, so we try to do peer tutoring. So between robot and ASD student. At that time, ASD student teaches something to robot. On the other hand, so ASD student and small child, peer, so we cannot realize any peer tutoring. So between, okay, so normal child and ASD student. So in this way, so at the time I asked the ASD student, why can you wait? Oh, this robot is now thinking. Yeah, very interesting. So 5 or 6 years ago, so before COVID-19 pandemics, okay? So therefore, so this is what I want to say. The point is how to use robot, okay? So and then, so this is second comment to you, including me. Actually, so you know, so he explains about the importance of innovation, okay? New innovation generate new risk, okay? In order to solve new risk, we conduct new innovation, okay? So this is innovation risk loop. We never escape from the loop. So therefore, we have to, okay, so yeah, here, so we have to discuss how to deal with the LC problem, of course. Yeah, ethics, law, and social interaction or implementation. Yeah. So now, so the rapid growth of AI is really a big problem. On the other hand, the robot performance is not so rapidly increasing. Okay, so comparing to the enhancement of AI. Therefore, so we have to consider we should stop here a little. Okay, yeah. Okay, thank you very much.
Yeah, thank you. So we have heard that maybe we should stop now. Do you think we should stop now?
Not necessarily, no. So that was a pause, right? We need to pause. But I think going back to what Jan Lekun is actually saying, right? It's actually dangerous to disagree with Jan, by the way, but I'll try. One of the things that he's actually not explaining in this video is that the robot or the learning that we're talking about here, we're just reproducing the frame, right? What do we see from the outside, right? Whatever processes are happening inside, that's what we're struggling with when we're talking about the process of growth or the process of understanding, the process of learning. In order for me to actually build any complete understanding of any actions, right, looking at it from the outside, yeah, I can reproduce it, but the motivation behind it or the process that gets me to that, to that point, that's the point. That's the thing that humans have, robots do not. So if I am going to actually mitigate this in the human sense, I need to look at the process. If I'm going to actually mitigate this from the robot sense, I just need to look at the outcome. So those are the two perspectives that I have to address. But if I'm building that action intentionally, I can also look at the process. So in this particular case, we are learning from the video. The robot is actually reproducing this, but what is the actual method of getting from where you start the action to where you get the action completed? You're just reproducing results.
So one more thing. So actually, so now, the problem is in the architecture of end-to-end learning. So therefore, so we think everything is black box. Therefore, so today, so I wanted to say the importance of topological intelligence. Okay, so we can translate so knowledge graph and others. So actually, some audience said to us, so translation. Okay, so sorry. So actually, in case of ChatGPT, so we obtain text data, symbolic data. This is the point. Okay, so we can translate the meaning of text data. So according to our aim, oh, this is nonsense, so I can trash. Oh, this is very useful, so I can use. On the other hand, in case of transformer for robot, the robot cannot stop. Yeah, this is a problem. So 95% is successful, but we cannot use such kind of robot in daily life. Okay, 100 performance is required. So if we use robot in daily life, this is different from ChatGPT or LLM.
Okay, so embodiment means something extra, some extra requirements and some extra difficulties. Peter, what do you think about
only
the difficulties of this?
One thing. So if you go to the street and you ask an ordinary people what they think about the robotics AI, the problem, most of the answer may be overestimated or underestimated. What is the robotics and AI? That's the problem. So what can be our most important message that help to the society to handle this problem in its but anyway, we also don't know. We also not we cannot agree about the AI robotics, but we have to discuss, and it is not our competency. Okay, sorry.
So transparency is important in this way, definitely, and also personalization, as we have heard from the audience. And I would like to pull this conversation down to the ground a little bit. So do you think that maybe there is a way to expand on the currently existing safeguards for robots and extend it to an intelligent robotics system or an AI robotics system as well? I'm not an expert of currently standing robotic guardrails as well, but maybe we have someone who can tell us a bit more about that.
Can you rephrase a little bit? I'm still thinking. That was a lot of input for
yeah,
me
so
during
so
the last
we
half an hour.
we were talking about basically applying robotics and AI in a way that it could be maintained in a closed or limited environment according to our personal needs. And I think standard digital automation is also something that should be guardrailed as well. I'm not sure if these principles could be applied to more modern applications as well or not.
I see. I will be completely honest with you. I don't think that let the average human being as close to the AI world as now it is intended. It's really dangerous. So I've been thinking for, I don't know, maybe at least 5 years, the best use of AI. We should completely, not completely, we should completely put aside from human beings at this point, because we are not ready for that. But there are certain areas where it could make really wonder. For example, designing materials, pharmaceutical agents, or whatever. That's brilliant. Putting together structures to create, I would say, some fundamental things which can be really useful for us and maximize the outcome. That's, I would say, it's safe, but we don't know how to act. The biggest problem, actually, not the AI itself, the human being. Just let me go back a little bit to kids. I've seen so many cases that parents in the restaurants just give tablets to the children just to be quiet. Are we ready for that? No. Because those people will give the AI tools for the kids. And it will result in a really, really huge distance between certain type of people who know how to handle those things and the rest of them won't. And that's I don't want to be pessimistic, but I see the trends. You can use your phone for dumb scrolling, or you can use your phone to create something useful. But most of the cases, if the people, the people who can learn what is the good use of things, they can use it as a tool. The rest of them, well, it's extremely dangerous. So this is my personal opinion. It should be put aside from humanity. Well, it should be left to the experts for certain fields. This is what I mentioned previously. We should focus on certain fields, and when we have enough experience, yes, we can, I would say, simplify a few things and start to interact with younger generations, or start to carefully experiment with social groups or whatever. But in this way, I don't think that we are not ready for that.
Do you think there is a way to personalize guidelines? What should we consider in this way? What are the key factors in the future of robotics?
I can actually try to answer this one, right? If you look at a lot of the writing about AI guardrails, right? We are looking at, if I take, for instance, I'll mention names. We've got NVIDIA, right? NVIDIA NeMo, it's looking at text data. If you're looking at AWS, they're looking at text data. But the training data of these models is actually multimodal, right? Which means that there is actually a topological gap that we need to fill, right? That's the one part. So when we are talking about the guardrails, one of the other things that you hear is that, oh, we should actually put a human in the loop. I mentioned in the number of transactions that we deal with in a day, 19 trillion transactions. A human in the loop is not a solution. And the other part of it, depending on the type of data that you're dealing with, that human in the loop has to have a specification of a mathematician. And how many mathematicians do we have available to these companies that are actually providing these rules? So if we are looking at, can we make these models safe? The question is, can we scale our mathematics? So that's where I would like to leave it, that if we cannot scale our access to data, if we cannot scale our access to the expertise that we can actually qualify in, let's say in mathematics, it's not the only solution, but everything is mathematics in the end. So I actually crushed myself. So in the end, what I'm saying is, if we don't scale the way to how to actually mitigate these risks, there is nothing that is going to happen by consensus, right? We are living in a world that is actually changing every day, right? So consensus is not going to be the way forward. It means that we really need to understand what we are doing, or we have to hope that we can actually turn the tap off. On the other hand, I am actually also lucky enough to work in a company that is also advancing quantum computing. So if I'm looking at quantum-inspired algorithms and what you can do with the same data that we were struggling with, or the explainability of neural networks, that is actually an angle that we haven't actually covered. So if we're talking about AI, yeah, there is actually AI on there. But combine AI and quantum-inspired or quantum algorithms, to be exact, that's a different story, right? That's a different level of acceleration. So there are many things we can think about, but the main thing is that we can't stop learning.
Okay, then I would like to assemble a list with you. A list of the most important key factors on driving intelligent robotics. So we have heard, I think, at least two. So one of them was compute and algorithms. That's something we have to scale. And the second one you mentioned is also the expertise. But in case of intelligent robotics, this expertise cannot be just mathematicians. Mathematicians can write really good neural networks and whatever, but it needs to be something social, psychological, ethological, and I don't know if any of you can give me like a complete list of key factors, or where should we go for? Yes,
can
please.
I steal some time to define what I meant by a mathematician?
Yes, please.
A mathematician, I'm not defining as someone who actually solved the equations, right? I'm actually applying mathematical thinking,
okay.
Right? So it's a broader definition that includes everybody, even in the arts.
Okay.
Because if I'm talking about the origins of some of these ideas, it's not in pure mathematics, right? It's actually in the applied field. But if I'm talking about controlling something, I need to actually look at the mathematical thinking behind it, not the pure mathematics. In that
So
sense.
you meant more like algorithmic minds instead of mathematicians. Okay. So what else do we need? Yes, please.
One thing, yeah. So human in the loop machine learning is very important. Yeah. So and also, so we have discussed the importance of society in the loop machine learning. So we have to evaluate the value of AI in the society, and then so we try to use AI. Okay. So the last one is robot in the loop machine learning. So before doing something, so in human student or something, so we can use the robot. Yeah. So this is robot in the loop machine learning. So anyway, so today I don't have enough time, but so next time I will come here again, and then so we will discuss. Okay. So last one. Okay.
Yes. Sorry.
Okay.
Yeah, Peter, do you want to? Okay. Yeah, so I would say that I have brought one more figure we should discuss, and we will not have time to discuss. But I would really like to ask the audience to give us some first impressions on what I will show you, and then maybe in 2 minutes we can answer it in the stage as well. So here is a figure of rating X. About the projected prices of operation of a humanoid robot per hour, projected up until 2045. And you can see the line where it crosses, well, the Hungarian minimum wage per hour. It's projected in 5 years. Of course, this is not counting for services and whatever extra included in these humanoid robots, but it means that humanoid robots are basically entering the era of mass manufacturing soon. So what do you think would be an advantage or a disadvantage of a robotized society? Anyone has some ideas on what to fear and what to wait for, actually? Who would like to buy a humanoid robot if it's cheaper than a car? Hands up, please. Okay, that's 5 people in the whole room.
If it's the whole room, then 6.
Okay, sorry, 6. Okay, then it's 6 people out of much more. So can you give us an idea? Can we pass the mic to them just to explain why you will buy a humanoid robot?
I will be very simplistic. So I would consider it as a modern slave. I'm sorry. I know we are at ethology as well, but I would do the dirty job with it.
So you would look at it like a tool, basically?
Yes, with a tool.
Okay. There was another gentleman who would buy one. Yeah. Sorry, please.
I mean, I wouldn't want to buy one. I just want to give just a counter thought, because obviously the whole discussion was around humanoid robots, and I just wanted to maybe give a bit of a food for thought for everyone about. So I think really there's no need for a robot to look like a human, right? I don't think there is any need to use a humanoid embodiment in robots. And also in the first video what we've seen, the video was focusing on object manipulation mostly, very specific fine-tuning skills, and no social skills whatsoever, no sociality expression on that robot whatsoever. So then why to have 5 fingers and why to look like a humanoid? I think a robot should look according to its function, right? So I think when a robot looks like what it was made for, then it will meet the user expectations. And so this is why I would never buy a humanoid robot.
Okay, but there is room for tool-like robots in this case. Yes, please.
Have you mentioned for what purpose? Because a car, we know what this is for.
Exactly.
Buy a robot
Thank you very much. So we cannot even answer. It's not comparable. So car, we know it's good for what, but robot for what purpose? I would buy maybe one, but not another one. Thanks.
So you mean that we first need to prove the usefulness of that such a robot?
Or just the purpose?
Just the purpose, at least. Okay. Okay. So we have so far assembled the profile of the tool-like robots in this sense, and we have received some critique that the robot should not just be a tool, or maybe should be something else or something higher level. And then I think I will just ask our professionals here for a last round, because we have talked about the first robots. I would like to ask you about the last robot. Will the last robot be an all-useful tool, or will it be closer to some sentient being, or at least mimic some kind of social skills and mimic some kind of a personality there? And let's start with Péter now, because he was the last one.
I say again, it is out of engineering competency.
Based on the need, definitely. So actually, I don't like that picture that there is a robot inside my house. So as a tool, yes. If it can help us, yes. But it shouldn't be completely inside our life.
Thank you.
So, looking at the spirit of the question, the last robot will just be there to switch off the lights. So it doesn't need to be complicated at all.
János, what do you think about the last robot?
I would need a robotic twin who can do most of my job, and then I can have more time for other jobs. So that's what I would do.
Definitely.
Okay, I want to duplicate mine. Yeah, so this is a similar opinion to you. Yeah, I need one more now. Now robot.
There is now a robot, you know.
Okay.
You need or your wife need.
But so if I have now robot, so I and now robot say, oh, please do it. Oh, please do it. This is not my work. Okay. As a result, nothing. I cannot do anything.
Okay, so then the question rises that will your identical twin robot require another robot to be their twin as well? Yeah, so at this point, I would like to say that there are some things which could be replicated, but roundtable talks like this and interdisciplinary talks like we had with the audience as well, and thank you very much for chipping in. This is something we cannot replicate at this moment, at least. And before we switch off the lights on the stage, I would like to ask you for a huge round of applause for our professors here. And thank you very much for the participation. And I think we are due to have a short break, if I'm not mistaken, but you will not run away, so with a coffee in hand, we can continue the discussions. Thank you.